Chapter 7, Plate Tectonics. The big idea, what is the theory of plate tectonics? Lesson 1, the continental drift hypothesis. Pangea. Did you know that Earth's surface is on the move? Can you feel it each year? North America moves a few centimeters farther away from Europe and closer to Asia. That is several centimeters, or about the thickness of this book. Even though you don't necessarily feel this motion, Earth's surface moves slowly every day. Nearly 100 years ago, Alfred Wegener, a German scientist, began an important investigation that continues today. Wegener wanted to know whether Earth's continents were fixed in their positions. He proposed that all the continents were once part of a supercontinent called Pangea. Over time, Pangea became breaking apart and the continents slowly moved to their present positions. Wegener proposed the hypothesis of continental drift, which suggested that continents are in constant motion on the face of Earth. Alfred Wegener observed the similarities of continental coastlines now separated by oceans. Look at the outlines of Africa and South America in Figure 1. Notice how they could fit together like pieces of puzzles. Hundreds of years ago, map makers noticed this jigsaw puzzle pattern as they made the first maps of the continents. Evidence that continents move. If you had discovered continental drift, how would you have tested your hypothesis? The most obvious evidence for continental drift is that the continents appear to fit together like pieces of a puzzle. But scientists were skeptical, and Wegener needed additional evidence to support his hypothesis. Climate clues. When Wegener pieced Pangea together, he proposed that South America, Africa, India, and Australia were located close to Antarctica 280 million years ago. He suggested that the climate of the southern hemisphere was much cooler at the time. Glaciers of the southern hemisphere was much cooler at the time. Glaciers covered large areas that are now parts of these continents. These glaciers would have been similar to the ice sheet that covers much of Antarctica today. Wegener used climate changes to support his continental drift hypothesis. He studied the sediments deposited by glaciers and beneath these sediments. Wegener discovered glacial grooves, or deep scratches in rocks made as the glaciers moved across land. Figure 2 shows that where the glacial features are found on neighboring continents today. These continents were once part of the supercontinent Pangea, when the climate in the southern hemisphere was cooler. Fossil clues. Animals and plants that live on different continents can be unique to the continent alone. Lions live in Africa but not in South America. Kangaroos live in Australia but not on any other continent. Because oceans separate continents, these animals cannot travel from one continent to another by natural means. However, fossils of similar organisms have been found on several continents separated by oceans. How did this happen? Wegener argued that these continents must have been connected sometime in the past. Fossils of a plant called the Glossopteris have been discovered in rocks from Southern America and Africa, India, Australia, and Antarctica. These continents are far apart together that separates them. Figure 3 shows that when the continents were part of Pangea 225 million years ago. Glossopteris lived in environment, therefore the climate of this region, including Antarctica, was different than it is today. Antarctica has a warm and wet climate. The climate has changed drastically from what it was 55 million years earlier when glaciers existed. Rock clues. Wegener realized he needed more evidence to support the continental drift hypothesis. He observed that mountain ranges like the ones shown in Figure 4 and rock formation on different continents had common origins. Today, geologists can determine when these rocks formed. For example, geologists suggest that large-scale volcanic eruptions occurred on the west coast of Africa and the eastern coast of South America. At about the same time, hundreds of millions ago, the volcanic rocks formed from the eruptions are identical in both chemistry and age. Refer back to Figure 1 if you could superimpose similar rock types onto the maps. These rocks would be the area where Africa and South America fit together. The Caledonian mountain range in northern Europe and the Appalachian Mountains in eastern North America are similar in age and structure. They are also composed of the same rock types. If you placed North America and Europe next to each other, these mountains would meet and form one long continuous mountain belt. Figure 4 illustrates where this mountain range could be. What was missing? Wegener continued to support the continental drift hypothesis until his death in 1930. Wegener's ideas were not widely accepted until nearly 4 decades later. Why were scientists skeptical of Wegener's hypothesis? Although Wegener had evidence to suggest that continents were on the move, he could not explain how they moved. One reason scientists questioned continental drift was because it is a slow process. It was not possible for Wegener to measure how fast the continents moved. The main objection to the continental drift hypothesis, however, was that Wegener could not explain the forces caused the continents to move. The mantle beneath the continent and the seafloor is made of solid rock. Wegener needed more scientific evidence to prove his hypothesis. However, this evidence was hidden on the seafloor between the drifting continents. The evidence necessary to prove continental drift was not discovered until long after Wegener's death.